Hi, welcome to Alibaba Cloud Training Program. For this training, you will learn about the Python data visualization. The training program covers the topics related to the Python data visualization. From this training, we will learn what is Python visualization and how to use Python visualization tools to generate plots to visualize data. This training is for people who have Python programming experience and want to learn data visualization skills. It will take around 45 minutes to complete. The training covers the following 4 topics: Data visualization overview, Python visualization tool, matplotlib, Python visualization tools, pandas and seaborn, and finally, a practical Python data visualization example. At the end of the training, we have prepared a 45 minutes test. This will let you check the effectiveness of the training you have learned. Hi, welcome to Alibaba Cloud Training Program. For this training, we will cover the overview of data visualization. This is the objective of this training session. We should know what is data visualization, the importance of data visualization, and some basic visualization plots. Data visualization is a generic term used to describe any attempt to help understand data by providing visual representation. It is a process of extracting and visualizing the data in a very clear and understandable way without any form of reading or writing by displaying the results in the form of pie charts, bar graphs, statistical representation, and through graphical forms as well. In data visualization, the primary goal is to convey the information efficiently and clearly without any deviations or complexities in the form of statistical graphs, information graphs, and plots. To illustrate the importance of data visualization, let's look at this table. The table consists of 30 samples. 2 features: sepal length and sepal width are measured from each sample. Okay, can you tell the distribution of each feature or the relationship between these 2 features? Next, let's look at the scatter plots and histograms of these 2 features. It is very obvious that there exists a positive relationship between these 2 features, and it tends to have a high middle and low side distribution for each feature. From this example, we can see understanding countless digits is difficult. This is where data visualization comes into play. More specifically, data visualization can be used in the following aspects. By using graphical representations of information, people are able to see large amounts of data in clear, cohesive ways and draw conclusions from that information. It saves everyone's time and makes the information much easier to comprehend. Data visualization can help people to discover emerging trends in data. It also makes it easy to spot outliers in data. Data visualization can help people to recognize parameters that are highly correlated, then to find some important patterns. After uncovering new insights from visual analytics, the next step is to communicate those insights to others. Using charts, graphs, or other visually impactful representations of data is important in this step because it's engaging and gets the message across quickly. There are so many plots in data visualization, but due to the time limitation, we will only introduce 5 most commonly used plots. These are histogram, line plot, bar chart, box plot, and scatter plot. A histogram is an accurate representation of the distribution of numerical data. It is an estimate of the probability distribution of a continuous variable or a quantitative variable and was first introduced by Carl Pearson. To construct a histogram, the first step is to bin or bucket the range of values, that is, divide the entire range of values into a series of intervals, and then count how many values fall into each interval. The bins are usually specified as consecutive non-overlapping intervals of a variable. The bins, or intervals, must be adjacent and are often, but not required to be, of equal size. The x-axis represents discrete bins or intervals for the observations. For example, observations with values between 1 and 10 may be split into 5 bins. The values range from 1 to 2 would be allocated to the first bin. 3 to 4 would be allocated to the second bin, and so on. The y-axis represents the frequency or count of the number of observations in the dataset that belongs to each bin. A line plot is generally used to present observations collected at regular intervals. The x-axis represents the regular interval, such as time. The y-axis shows the observations ordered by the x-axis and connected by a line. Line plots are commonly preferred when we are to analyze a trend spread over a time period. A bar graph, also known as a bar chart or bar diagram, is a visual tool that uses bars to compare data among categories. A bar graph may run horizontally or vertically. A bar graph is generally used to present relative quantities for multiple categories. It differs from a histogram graph in the sense that a bar graph relates 2 variables, but a histogram relates only 1. The important thing to know is that the longer the bar, the greater its value. Bar graphs consist of 2 axes. The x-axis represents the categories and are spaced evenly. The y-axis represents the quantity of each category and is drawn as a bar from the baseline to the appropriate level on the y-axis. In descriptive statistics, a box plot is a convenient way of graphically depicting groups of numerical data through their qualities. Box plot is generally used to summarize the distribution of data. The x-axis is used to represent the data sample, where multiple box plots can be drawn side by side on the x-axis. The y-axis represents the observation values. A box is drawn to summarize the 25th percentile, median, and the 75th percentile of data. Lines called whiskers are drawn extending from both ends of the box with the length of the IQR, which is calculated as 1.5. The difference between the 75th and 25th percentiles to demonstrate the expected range of sensible values in the distribution. Observations outside the whiskers might be outliers and are drawn with small circles. A scatter plot is a type of mathematical diagram using Cartesian coordinates to display values for typically two variables for a set of data. If the points are color-coded, you can increase the number of displayed variables to 3. A scatter plot is generally used to summarize the relationship between two paired data samples. Paired data samples means that two measures were recorded for a given observation, such as the weight and height of a person. The x-axis represents observation values for the first measure, and the y-axis represents the observation values for the second measure. Each point on the plot represents a single observation. This is all for this session. Thank you for joining Alibaba Cloud Training Program. Goodbye. Hi, welcome to Alibaba Cloud Training Program. For this training, we will cover the Python visualization tools Matplotlib. This is the objective of this training session. We should know the overview of Python data visualization tools, the overview of Matplotlib, the difference of two plotting interfaces in Matplotlib, the basic plotting process in Matplotlib, and finally, how to control the appearance of plots in Matplotlib. Plotting data in the Python ecosystem is a good news, bad news story. The good news is that there are a lot of options. The bad news is that there are a lot of options. Because of this variety, it can be really challenging to figure out when to use which option. Due to the limit of time, we will only introduce 3 most basic tools in this and the next sessions. They are Matplotlib, Pandas, and Seaborn. Matplotlib is a plotting library for the Python programming language and its numerical mathematics extension, NumPy. It provides an object-oriented API for embedding plots into applications using general-purpose GUI toolkits like tkinter, wxPython, Qt, or GTK+. There is also a procedural Pylab interface based on a state machine like OpenGL, designed to closely resemble that of MATLAB, though its use is discouraged. CFI makes use of Matplotlib. Matplotlib, which was originally written by John D. Hunter, has an active development community and is distributed under a BSD-style license. Michael Drootboom was nominated as Matplotlib's lead developer shortly before John Hunter's death in August of 2012 and was succeeded by Thomas Casewell. Matplotlib is the grandfather of Python visualization packages. Many of the tools, especially Pandas and Seaborn, are just thin wrappers over Matplotlib. It is extremely powerful, but with that power comes complexity. You can typically do anything you need using Matplotlib, but it is not always so easy to figure out. As of 23rd June 2017, Matplotlib 2.0.x supports Python versions 2.7 through 3.6. Matplotlib 1.2 is the first version of Matplotlib to support Python 3.x. Matplotlib 1.4 is the last version of Matplotlib to support Python 2.6. All our examples in this training program are run by Jupyter Notebook on ECS platform. Now let's see an example. Let's log in to Alibaba Cloud. Input username and password. Click Log In. Here, I have already created an ECS instance in Alibaba Cloud. Copy the EIP of the ECS. Open the Windows Remote Desktop to log in the ECS. Paste the EIP. Click Connect. Ensure you have installed Jupyter Notebook. Here I have already installed the Jupyter Notebook. Open the CMD window. Then type in Jupyter Notebook command. Which will open a browser automatically like this. You can open a new or existing notebook. Now let's demonstrate how to plot in Jupyter Notebook with Matplotlib. First, import Matplotlib. Just as we use the NP shorthand for NumPy and the PD shorthand for Pandas, we will use some standard shorthands for Matplotlib imports. Second, embedding graphics in Jupyter Notebook. The Matplotlib inline command will lead to static images of your plot embedded in the notebook. Third, setting styles. We will use the plt.style directive to choose appropriate aesthetic styles for our figures. Here we will set the classic style. You can run plt.style.available command to get all available styles. Fourth, create data. Let's use np.linespace to create 100 evenly spaced numbers over 0 to 10 as x. Use np.sin to create y. Fifth, plot. Use plt.figure to create a figure object. Pass x and y to the plt.plot method to plot. Run this cell, then a figure of sine curves will show below. Sixth, save figure. You can save a figure using the savefig command. Here, we save the previous figure as a PNG file. A potentially confusing feature of Matplotlib is its dual interfaces. A convenient MATLAB-style state-based interface and a more powerful object-oriented interface. We'll quickly highlight the differences between the two here. Matplotlib was originally written as a Python alternative for MATLAB users, and much of its syntax reflects that fact. The MATLAB-style tools are contained in the PyPlot PLT interface. For example, the following code will probably look quite familiar to MATLAB users. It's important to note that this interface is stateful. It keeps track of the current figures and axes, which are where all PLT commands are applied. You can get a reference to these using the plt.gcf or getCurrentFigure and plt.gca getCurrentAxisRoutines. While this stateful interface is fast and convenient for simple plots, it's easy to run into problems. For example, once the second panel is created, how can we go back and add something to the first? Fortunately, there is a better way. The object-oriented interface is available for these more complicated situations and for when you want more control over your figure. In the object-oriented interface, the plotting functions are methods of explicit figure and axis objects, rather than depending on some notion of an active figure or axis. To recreate the previous plot using this style of plotting, you must do as the following code. To conclude, for more simple plots, the choice of which style to use is largely a matter of preference, but the object-oriented approach can become a necessity as plots become more complicated. Here we will take a first look at creating a simple line plot in Matplotlib. For all Matplotlib plots, we start by creating a figure and an axis. In their simplest form, a figure and axis can be created by following the code. Please refer to the slide. In Matplotlib, the figure, an instance of the class PLT figure, can be thought of as a single container that contains all the objects representing axes, graphics, text, and labels. The axis, an instance of the class plt.axis, is what we can see above, a bounding box with ticks and labels, which will eventually contain the plot elements that make up our visualization. Once we have created an axis, we can use the ax.plot function to plot some data. Let's start with a simple sinusoid. If we want to create a single figure with multiple lines, we can simply call the ax.plot function multiple times. That's all there is to plotting simple functions in Matplotlib. Next, we'll now dive into some more details about how to control the appearance of the axis and lines. The first adjustment you might wish to make to a plot is to control the line colors and styles. The plt.plot function takes additional arguments that can be used to specify these. To adjust the color, you can use the color keyword, which accepts a string argument representing virtually any imaginable color. If no color is specified, Matplotlib will automatically cycle through a set of default colors for multiple lines. The color can be specified in a variety of ways as follows. Similarly, you can adjust the line style using the line style keyword. The line style can be specified in two ways as follows. Matplotlib does a decent job of choosing default axis limits for your plot, but sometimes it's nice to have finer control. The most basic way to adjust axis limits is to use the plt.xlim and plt.ylim methods. Another useful related method is plt.axis, which allows you to set the x and y limits with a single call by passing a list that specifies xmin, xmax, ymin, and ymax. As the last piece of this session, we'll briefly look at the labeling of plots, titles, axis labels, and simple legends. When multiple lines are being shown within a single axis, it can be useful to create a plot legend that labels each line type. Again, Matplotlib has a built-in way of quickly creating such a legend. It is done via the, you guessed it, plt.legend method. Though there are several valid ways of using this, I find it easiest to specify the label of each line using the label keyword for the plot function. Finally, let's see how to make adjustments in object-oriented interface. While most PLT functions translate directly to AX methods, this is not the case for all commands. In particular, functions to set limits, labels, and titles are slightly modified. For transitioning between MATLAB-style functions and object-oriented methods, make the following changes. In the object-oriented interface to plotting, it is more often convenient to use the ax.set method to set all these properties at once, rather than calling these functions individually. Due to time constraints, we will only introduce basic usage of Matplotlib. For more information, please visit the official website of Matplotlib. This is all for this session. Thank you for joining Alibaba Cloud Training Program. Goodbye. Hi, welcome to Alibaba Cloud Training Program. For this training, we will learn about other Python visualization tools, Pandas and Seaborn. This is the objective of this training session. We should know the overview of Pandas, the basic visualizations in Pandas, the overview of Seaborn, and a few data statistical visualizations in Seaborn. Pandas stands for Python Data Analysis Library, which is a Python package providing fast, flexible, and expressive data structures designed to make working with relational or labeled data both easy and intuitive. It aims to be the fundamental high-level building block for doing practical, real-world data analysis in Python. It is one of the most powerful and flexible open-source data analysis or manipulation tools. The two primary data structures of Pandas, Series 1-dimensional and DataFrame 2-dimensional, handle the vast majority of typical use cases in finance, statistics, social science, and many areas of engineering. For our users, DataFrame provides everything that ours DataFrame provides, and much more. Pandas has integrated well with Matplotlib. The plot method on series and DataFrame is just a simple wrapper around plt.plot. We can easily create decent-looking plots directly on series and DataFrame after basic data preparation and analysis. What's cool about Pandas is that it takes data like CSV or TSV file or an SQL database and creates a Python object with rows and columns called DataFrame that looks very similar to table in a statistical software. Think Excel or SPSS, for example. People who are familiar with R would see similarities to R too. This is so much easier to work with in comparison to working with lists and or dictionaries through for loops or list comprehension. We will demonstrate the basics in Panda visualization. The default plot function will produce line plot. The following steps will need to be completed to produce a line plot. First, we should create a DataFrame pd.dataframe method. Then, we can easily create a line plot by the df.plot method. Finally, we can plot one column versus another using the X and Y keywords. Here is an example to create some bar plots. We can create a default bar plot with the df.plot.bar method. By passing stacked equals true, we can create a stacked bar plot. To get horizontal bar plots, use the df.plot.bar method. We can plot histograms using the plot.hist method. We can specify a number of bins by bins keyword. To plot different histograms for each column using df.hist method. Boxplot can be drawn calling dataframe.plot.box or dataframe.boxplot to visualize the distribution of values within each column of the data frame. Scatterplot can be created using the dataframe.plot.scatter method. You should declare columns of the data frame corresponding to x-axis and y-axis by passing x and y keywords in the method. Due to time constraints, we can only introduce the basic visualizations in Pandas. For more details on Pandas, please visit the official website of Pandas. Here is another powerful visualization tool, Seaborn. Unlike Pandas, Seaborn is a pure Python data visualization library based on matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. It has more aesthetically pleasing default style options and 4 specific charts, especially for visualizing statistical data, and it makes creating compelling graphics that may be complex with matplotlib easy. Seaborn aims to make visualization a central part of exploring and understanding data. Its dataset-oriented plotting functions operate on data frames and arrays containing whole datasets and internally performs the necessary semantic mapping and statistical aggregation to produce informative plots. Let's take a look at a few statistical data plots available in Seaborn. Often in statistical data visualization, all you want is to plot histograms and joint distributions of variables. Plotting histograms is relatively straightforward in matplotlib. Rather than a histogram, we can get a smooth estimate of the distribution using a kernel density estimation, which Seaborn does with sns.kde plot method. What's more, histograms and KDE can be combined using sns.distplot method. When you generalize joint plots to datasets of larger dimensions, you end up with pair plots. This is very useful for exploring correlations between multidimensional data when you'd like to plot all pairs of values against each other. Visualizing the multidimensional relationships among the samples is easy as calling sns.pairplot. The faceting is defined by a categorical variable or variables. In some circumstances, we want to plot relationships between set variables in multiple subsets of the data with the results appearing as panels in a larger figure. This is known as facet plot. Each panel plot corresponds to a set value of the variable. Seaborn's facet grid makes this extremely simple as follows. Similar to the pair plot we saw earlier, we can use sns.jointplot to show the joint distribution between different datasets, along with the associated marginal distributions. The joint plot can even do some automatic kernel density estimation and regression. Due to time constraints, we only introduced a few data statistical visualizations in Seaborn. For more information on Seaborn, please visit the official website of Seaborn. In summary, there are multiple options for visualizing your data in the Python world. Because of this variety, trying to figure out which ones work for you will depend on what you're trying to accomplish. To some degree, you need to play with the tools to figure out if they will work for you. I don't see one clear winner or clear loser. With regard to the three tools we introduced, although Matplotlib is the most prominent Python visualization library, there are other more modern tools that are more easy to use. Pandas is handy for simple plots, but you need to be willing to learn Matplotlib to customize. Seaborn can support some more complex visualization approaches, but still requires Matplotlib knowledge to tweak. The color schemes are a nice bonus. This is all for this session. Thank you for joining Alibaba Cloud Training Program. Goodbye. Hi. Welcome to Alibaba Cloud Training Program. For this training, we will introduce a practical Python data visualization example. In this session, we will demonstrate some data visualizations on the Iris dataset with Pandas, Seaborn, and Matplotlib in Python. This is the objective of this training session. We should know how to create plots with Pandas, Seaborn, and Matplotlib in Python, the application of data visualization in the data analysis, how to incorporate data visualization into your own workflow. Let's look at the dataset first. Iris dataset is a famous multivariate dataset introduced by the British statistician and biologist Ronald Fisher. The dataset consists of 150 samples from each of 3 species of iris: Iris setosa, Iris virginica, and Iris versicolor. 4 features were measured from each sample: the length and the width of the sepals and petals in centimeters. Based on the combination of these 4 features, Fisher developed a linear discriminant model to distinguish the species from each other. Now, let's start to analyze the dataset. First, we'll import Pandas, Seaborn, and Matplotlib. Next, we'll load the iris flower dataset as a data frame in Pandas. Then, use iris.head command. We can check what's in the iris data. Jupyter Notebook prints the first 5 rows of the data frame. Before visualizations, we can see how many examples we have in each species. There are equal samples in each species. The first way we can plot things is using the .plot extension from Pandas data frames. We'll use this to make a scatter plot of the iris features. From the plot, we can see there is a positive correlation between the length and the width of the sepals and petals. We can also use the Seaborn library to make a similar plot. A Seaborn joint plot shows bivariate scatter plots and univariate histograms in the same figure. We can see the distributions of sepal length and width accord with middle high, low side, which approximately obeys normal distribution. However, the distributions of petal length and width have no obvious characteristics. One piece of information missing in the previous plots above is what species each plant is. So, we'll use Seaborn's facet grid to color the scatter plots by species. We can see different degrees of positive correlation of sepal length and width among the three species. And the data ranges of petal length and width are also different among three species. That is to say, the three species are distinguishable by analyzing these four features. Next, we can look at an individual feature in seaborn through box plots, which demonstrates different distributions of the features among the three species. Another useful seaborn plot is the pair plot, which shows the bivariate relation between each pair of features. From the pair plot, we'll see that the Iris setosa species is separated from the other two across all feature combinations. A final seaborn plot useful for looking at univariate relations is the KDE plot, which creates and visualizes a kernel density estimate of the underlying feature. Also, we can see that the Iris setosa species is separated from the other two in KDE plots. Now that we've covered seaborn, let's go back to some of the ones we can make with pandas. We can quickly make a box plot with pandas on each feature split out by species. One cool and more sophisticated technique pandas has available is called Andrews curves. Andrews curves involve using attributes of samples as coefficients for Fourier series. The clustering data can be visualized by marking each class of curves with different colors. The curves of samples belonging to the same class are usually closer and form a larger structure. From this plot, we can see Iris versicolor and Iris virginica are two relatively close species, and Iris setosa is separated from the other two. Another multivariate visualization technique pandas has is parallel coordinates. Parallel coordinates plots each feature on a separate column and then draws lines connecting the features for each data sample. From this plot, we can see the cluster result of all samples. There exists 3 clusters which correspond to 3 species. A final multivariate visualization technique pandas has is radviz, which puts each feature as a point on a 2D plane and then simulates having each sample attached to those points through a spring weighted by the relative value for that feature. In short, it is a visualization technology that maps a series of points in multidimensional space to 2-dimensional space by nonlinear method. From this plot, we can also conclude that Iris versicolor and Iris virginica are 2 relatively close species, and Iris setosa has more different features. In conclusion, I hope you enjoyed this quick introduction to some of the quick, simple data visualizations you can create with pandas, seaborn, and matplotlib in Python. I encourage you to run through these examples yourself, tweaking them and seeing what happens. From there, you can try applying these methods to a new dataset and incorporating them into your own workflow. This is all for this session. Thank you for joining Alibaba Cloud Training Program. Goodbye. This is all for the training sessions of the Python data visualization. Let's recap. In the beginning, we have learned the overview of data visualization. We know what is data visualization, and we learnt some basic visualization plots. Then we learned a Python visualization tool, matplotlib. We know what matplotlib is, and we learned the basic plotting process and techniques in matplotlib. Later, we learned other two types of Python visualization tools, pandas and seaborn. We know the overview and basic visualizations approaches of both pandas and seaborn. And finally, we demonstrated a practical Python data visualization example. We know how to create plots with pandas, seaborn, and matplotlib in Python, and how to incorporate data visualization into your own workflow. I hope from this training you will be comfortable using Python visualization tools to analyze existing data and generating visualizations of that data, and will be able to effectively utilize tools and packages that are widely available to amplify your effectiveness and write useful programs. Thank you for joining our training sessions. Goodbye.